All right, so these are this is the breakdown of the notes of all the rules, the definitions or the rules for area for integral calculus. As you can see, these three that we've already gone over. Okay, now I'm going to go ahead and walk you through the next three or four. All right, next we have double areas. Okay, so double areas. We've got two functions, all right, that basically intersect three times and create all right, so they create two different areas. All right, so how do you figure this out with two different areas? Well, you've got, all right, the first area, all right, got to do top minus bottom. So g of x on top, f of x on the bottom. We do it's like two different problems. You do a problem for the first area, you work it out all the way, then you add it to the answer of the problem for your second area from B to C. So you do two different integrals, separate integrals. They must be separate because this integral has these, first of all, this integral is g of x minus f of x, which is totally different than f of x minus g of x. Secondly, this integral has from A to B, this integral is from B to C. Okay? So that's what makes it totally different. Double areas, just set it up just like this, okay, and work out, you know, this one first and this one second or side by side, but work them out separately. All right, work out separately, then add. All right, so work it out separately, then add. Okay, next we have negative areas. Negative areas are a little different, okay? There's no such thing as a negative area, but there is a definite integral that's going to yield a negative value. This area is going to end up being a negative area in your answer, okay? But that doesn't mean when you're asked to find area, just because you get a negative answer, that doesn't mean you should just keep it negative. So you need to anticipate that this is negative and multiply your integral by -1. But you're going to work the whole integral out, work the entire integral out as one problem, and then take the final answer and multiply it by -1 in order to make a positive. Okay, so work the entire integral out first. So work all the way out, then make it positive. All right? So work all the way out, then make it positive. This multiplying by the -1 should make your answer positive. All right. Now let's go to positive / negative areas. Okay? Notice you see x-intercepts. Set your function equal to 0. Set your function equal to 0 in order to find the x-intercepts. But it intersects 3 times. This is a negative area. Well, what happens when you add a negative area with a positive area? Well, they're going to cancel out, and I don't want that to happen, so I don't want it negative. I don't want this negative area in this case, since I'm finding area. Area is by definition not negative. So I'm going to fix this negative area for A1, area 1. I'm going to change it to positive by multiplying it by a -1. So I'm going to work all the way out separately. Work this out separately, then make it positive. Same thing here. All right, and then I'm going to add after I work these out separately. Okay, so work these separately. Okay, work them separately. All right, so that's pretty much it. And so let's move on to the next couple things. All right, here we go. Pause if you need to. Flippy, flippy. All right, spliced areas. Spliced areas are fun. Okay, let me zoom in a little bit here. All right, so spliced areas. Here you have this. You have an area under two curves. First, it's under g of x. First, it's this area under g of x. First, it's that area under g of x, and then it's under this area under f of x. So we got to find this area under g of x, which is the integral from a to b of g of x. Notice here, you're going to have to find an intersection point. Intersection point. Well, we know how to find intersection points. Now, we might have to use our calculator. If it's a decimal, we might have to store it. We might have to do something along those lines. But there's your intersection point. My bad. Here we go. All right, so B is an intersection point. You might have to find it. So the integral from a to b underneath g of x, separate, plus, then a new integral from b to c of this area under f of x. We're adding those two areas together to find the total area. So this equals total area. Okay? You see a lot of these problems on the AP exam asking you to set up integrals for total area there. All right, let's move on. Now, with respect to y, all right, so basically what we have is an area right here. Instead of integrating with respect to x, now we're integrating with respect to y because we're moving along the y-axis. We're integrating along the y-axis, okay? So you think of this point as, if you think of this point as f of y, comma y, and f of y, well, what is that a fancy way of? That's a fancy way of saying x. You're taking that x value and you're making those millions and trillions and thousands, and you're making those little rectangular Riemann sums that we talked about. Those little rectangles, adding them up, that Riemann sum, okay? You're making those. All right, but you're integrating it where? You're integrating across y. So you're integrating all these little rectangles that have an x height. All right, so you need f of y's. You want to add up all these infinite f of y's. All right, so we're integrating f of y dy. All right, now I know we haven't quite done one like this, so I'm going to do a quick example.